Hello Trig class, this video is for finishing up the lecture on section 9.2, which is the law of cosines. And I had presented the lecture notes. Also, I presented all but 3 out of the practice test questions in class. So what this video is for finishing those last 3 questions. Okay, this is the law of sines. Oh, let's go. I'll write it this way. So you can use any side that you wanted from a triangle in any of these positions. The angle that appears here on the right-hand side is the one that's opposite this side length C. So in a picture, this is what's going on. So if this is 75 degrees, then the side opposite, I've named that little c. And you've got the other 2 sides, which are 6 and 3. And that's our situation. So the law of cosines is to work out the other information in the triangle as long as you have the 3 side lengths, or you could have 2 side lengths and the angle between them. All right. So let's solve for this side length. So you just sum the other sides squared. So this part just looks like Pythagorean's theorem, and then you have an adjustment that's take away twice the product of the side lengths times the cosine of the angle in between those side lengths. And that's all things that you can get in a calculator, so I'll just get that right-hand side as one number. That's 35.683. And then if you square root that, that's 5.973. Okay, and then the fastest way to get the other information is the law of sines. Now that we know an angle and the length of the side opposite, we'll just use the law of sines, which says if you have the sine of an angle divided by the side length opposite it, then that has to be equal for the other 2 angles also. So it doesn't matter which one you do. I guess this one was named angle A because it's across from what I labeled as side A, so I'll go for that one. So that's going to be sine of A divided by the length opposite it, which is 3. So sine of the angle is 3 sine of 75 degrees divided by 5.973. If you get that on a calculator, that's 0.485. So that would make angle A the inverse sine of 0.485. And the calculator, that's 29.022. That'd be degrees. And then you can get B because it is 180 degrees in the triangle. So if you go 180 minus 75, because that's one of them, and then minus 29.022, then you'll get the other angle that we don't know yet. And that's 75.98. Okay, so that's how you apply the law of cosines. And let's take a look at the other two that I didn't have time to do in class. So this one is given three sides. Find out the rest of the information in the triangle. So we'll go ahead and do that. I don't have to draw a picture to solve it, but I'm going to draw pictures just to describe what I'm doing. So 9, 8, and 5 are the side lengths. And we'll go ahead and get the side length opposite the 9. And because that was side length A, I'll label that angle capital A. Okay. Then work with the side opposite the angle that you just labeled. And according to the law of cosines, that side squared is the sum of the other sides squared minus twice the product of the other side lengths times the cosine of the angle in between, because that's the law of cosines. So I know everything in there except for the angle. Everything else is a number, so we'll just keep going until we get the number. And so 81 is 25 plus 64 minus 80 cosine A. So that makes, let's see now, this would be 89. We put these two together, bring this one over, you get an 8. So 8's got to be 80 cosine of A. So the cosine of A is just 0.1. And then I'll get on my calculator the inverse cosine of 0.1. And I'll know the angle. Okay. That's 84.26. And that's degrees. Okay, so that's angle A. And I might as well use law of sines now that I have a angle known that's across the side I know. So I'll just use the sine of that angle divided by that side length is, go for whichever one of the other angles you want. I'll just do the B one then, so I'll say sine of B divided by 8. So in the picture this is B, but it doesn't matter which one I would go to. You just go about it the same way anyway. So the sine of B is 8/9 the sine of 84.26 if you multiply both sides by 8. So this is 0.8844. 0.8844. So B would be the inverse sine of 0.8844. And on what is that on a calculator? That's 62.18. And since there's 180 degrees in a triangle, you just go 180 minus what we found for A minus what we found for B, and then you'll get what C is. And that's 33.56. Okay. All right. I got one problem left, and that's this one. So you're given 3 side lengths. And let's do this angle, which I'll call that angle A, just to give it a name. And you use law of cosines, which said the side opposite squared is the sum of the sides, other 2 sides squared, minus twice their product, times the cosine of the angle across from that side. So everything in there is a number, except for the angle A, which we'll go get. Okay, so if you add these two, move to the other side, you'll get minus 313. And then that's equal to minus 2 times 13 times 13 times cosine of A. So if you solve for cosine of A, that is 313 divided by 2 times 13 squared. And that's 0.926 when you work it out in the calculator. So A is going to be the inverse cosine of 0.926, which is 22.17. Okay, it wants all the angles, so one will be 22.17, then we'll go get the others. Now that I've got an angle across from a side that I know its length, I can use law of sines and say that the sine of 22.17 divided by 5, the length of the side opposite, is equal to, let's call it B, sine of B divided by 13. So if you solve that for sine of B, by multiplying both sides by 13 and then dividing by 5 there on the calculator, yeah, that's 0.9813. So B would be the inverse sine of 0.9813. And that's 78.90. Okay, so 78.90. Then you subtract these two from 180, and you will get the last one. which makes it 78.9. Well, of course, it's going to be the same as the other one because they're two sides the same, so you're going to have one angle that's the same. All right, thank you.